Good morning, everyone. Uh, we are meeting on a Saturday morning, and we'll be just waiting for 5 to 10 minutes, 5 minutes more, so that more people can join. I can see quite a few people have already joined. So we'll be starting the session really soon. Till then, I'll just give you an understanding of how you can ask questions. So I believe that you will be seeing a couple of options on your screen. You can always ask any questions that you have from the Q&A section, and someone from the panel will answer those questions, or our mentor will take up that question and answer that question for you. Can I quickly have good morning messages flowing on the Q&A section so that I can understand that you're all active here? I see 4, 5 messages here. According to the attendance, this is quite low. Could you please tell me that you're present actively in this webinar? All right, perfect. All right, let's take this webinar ahead. So I'm Vijay, and I am the senior academic counselor at Unikaksha. I will also be helping you to understand what is about what is this webinar about, what is Unikaksha about. So I'll just give you a brief understanding of what this webinar is about. So when you book flights, okay, and there's no straight plane found through a destination, what we do is we use graph theory algorithms, and that's how airline finds connecting flights, and you can book your flights according to those. So this session is a live demonstration of those graph theories. Okay. And we have our trainer, Miss Veda. She is qualified in BE Computer Science and Engineering, and she's a department top at that time. And she has work experience in quite a few companies and projects. So she came from Caresoft Global as a team lead in machine learning domain, and she has a domain knowledge of deep learning, image processing, GCP and Google Cloud, etc. uh, you're going to have a very fun session for the next 1 hour, and it's going to be amazing with her. This is going to be a very informative session, so please be active. I will be coming in and out for different polls when we'll ask, and you'll be able to see me thoroughly through the session. About Unikaksha, we are an online platform which specifically helps students and working professionals to upskill themselves in their tech careers, and then get the opportunities of their dreams. So we have had more than 10,000 students today, which we have helped in the same manner that we are going to do it today as well. Okay, so I'll be handing the session over to Miss Veda so that she can take it ahead from here.
Yeah, thank you, Vijay, and I welcome everyone who have shown interest to this particular webinar. And I hope everyone's introduction topic today is the implementation of graph theory in Python to solve the airline challenge, right? So that's what we are going to see. So let's get started, okay? So I'm Vinodini. I'm a data science and machine learning corporate trainer in Unikaksha. So this is the planned agenda for the day. Okay. So what are the challenges in this particular airline? That is what we are going to focus. And after that, we will see what is graph theory. And meanwhile, we will see how this graph theory is going to solve this exact airline problem. And finally, we will analyze the opportunities of learning this entire Python language and to set career path for you. Okay. So to give an idea about that Python things. Okay. So let's get started. So first of all, what are the challenges the particular airline will face? Okay, so in a particular airline industry or in a particular airline company, what they will face is while a person is booking or a common person is booking any airline to certain source to destination. In that particular case, due to some issues, some weather problem, or there might be not an connecting flight is available, so there might be many n number of problems will be there, right? So to solve that particular thing, an airline industry will have an application, so that in that application what they will be incorporating is in this exact graph theory they are going to use, and they will apply all these graph theory technologies to find the solution. Okay, that's what this is the gist of the entire thing. So let's get started with the topics. Okay, so actually what does that means, each and first of all, before starting to this airline thing, everyone knew how to book a particular airline tickets, right? So if you want to go from a source to destination, and if that particular destination is not a particular hub or something, then you will be mapped to nearby airports, right? So that is the algorithm how this airline will work. So first of all, in this particular thing, an airline company is going to face a four kind of problems. Okay, what is that? What is the shortest way to get from A to B? Let's assume that your source is A, okay, and then your destination is B, and in that particular thing, the airline should find the shortest way to reach to that particular location, right? So that is their first problem. Then second thing, is there any way to go from C to D? For example, if they are in the B and they are just checking that is there any availability, we can go to C to D. So that thing also they should provide, right? So the third thing is if there is any traffic, or what is the traffic in airline? That means due to some weather, climate, or there might be an delay in flight due to some other reasons might be. So if while the final check is there, if there is any error, they will just stop that airplane, right? So those kind of traffics and heaviest things, during that kind of thing, they will face an issue. Okay, so what is the fourth thing? That is in between the airports, they will be finding the local hub. Okay, so what is that means? They will just, for example, while you are in the source A to B, in that particular case, while they are just shifting to A to B, and there is a issue in airport B, or there is a problem in landing to port B. Okay, that is the problem statement. Okay, so in that particular case, they wanted to check there is any C or D kind of an airport is available nearby, and then they can easily able to land their airplane, right? So these are all the problem statements. So for all these things, what is the only solution they wanted to give? That is, they wanted to find the nearby airports. Meanwhile, they can also find the shortest path of that particular location. So this is the problem statement of the any airline company. Okay, so this is the introduction. So now let's move to the what is graph and graph theory. Okay, so first of all, I hope everyone should be from a computer science background, or might have heard about something related to that, or someone is not into computer science background, or who is very much interested to learn about this. I will explain what is this particular graph theory is. Okay, so first of all, in programming or in any of the thing, there is a concept called data, right? So there will be always a data. So to save that particular data and to manipulate that or to use that particular thing is called called as data structures. Okay, so what is that data structures? It is a way of storing a data. That's it. Okay, so for easier access and easier performing any operations or traversing, so few kind of things, this data structures will help. Okay, so first of all, there are two types of data structure. One is the linear data structure. That means it is in a linear manner. That means it is in a horizontal, it stored the data in a horizontal way. That is like stack, queue, linked list, array. So these all concepts will come under the linear data structure. Okay, the one thing you wanted to understand is the linear data structure. It will store the data in horizontal format. That's it. Then there is a concept called non-linear data structure. Of course, by the name itself, you can understand it is the exact opposite of linear one. So non-linear data structure, it will store the data in a vertical format. That is from top to down approach, like that. Okay, so there are two types of non-linear thing. One is tree and another thing is graph. Of course, why tree and graph? Why there is already a data structure called linear thing is available. Why we need to discover this non-linear thing? Because there is a lag or the time space or time complexity it takes to manipulate or to find the output by using this linear data structure will be very low. Okay, so comparatively this graph and tree will give a good amount of output in a very less amount of time. That's why they might have introduced this non-linear data structure concept. Okay, so this is the introduction of what is graph. Then what is graph theory? According to this particular thing, the graph theory involves the graph. Okay, so I will explain what are all those graph things and what are all these things in the upcoming slides. Okay, so first of all, what is the thing is important? That is, it will solve the problem in a efficient manner, and then it will give a good amount of output in a good time complexity or space complexity. It is based on the problem statement. Okay, so that is why we are switching to this particular graph theory for this particular airline problem. Okay, so then okay, now you wanted to understand the terminologies in graph. Okay, so what are the terminologies means? You wanted to understand what is vertices, what is edge, what is path, what is directed graph, what is undirected graph. Okay, so if you understand this topic, then I'm implementing that in the airline problem, then it will be easier for you to understand. Okay, so what is vertices? Let's take this particular graph as a thing. Okay, so now this is A, B, C and D, right? So what are all the vertices are? That the A, B, C, and D. So the vertices in this particular graph. Okay, so what are the edges? That is from this location to this location. That is A to B, A to C, C to D, and B to C, right? So these are all the edges. That means what are all the possible ways you can travel? That is the thing called edges. Okay, so that is path. Okay, first of all, that means I'm just going to give a two vertices. That means A and B, or example, or A and C. From two vertices, what are all the paths available? Okay, let's this is Delhi, this is Chennai. So from here to here you want to travel. So what is the paths available? So that will be the path question. Okay, so from A to B, what are the paths available, guys? Like A to B and then A to C and C to B, right? So these are the paths. You can travel from A source to B destination. So this is called as path. Okay, so then after that, what is directed graph? That is, it will be having like there is a arrow here. Okay, so for example, if it is having an arrow from A to C, then it will not have an arrow from C to A. Okay, so you go by both ways. It is only a single way. If it is a directed graph, then it will be in a single way alone. Okay, so I will just show you things. So what is undirected graph? This particular graph is an undirected one. That means it will not have any directed arrow keys. That means it can move from both ways, like you can move from A to C or C to A. Okay, so these are all the things you wanted to understand in this particular graph terminologies. And once you're clear with that, we can while I'm explaining about the airline kind of problems, then it will be easier for you to understand. Okay, so first of all, I'm just giving an example for network and their component. What is that? So network is an airline. So now what are all the vertices I explained here, right? So assume that A, C, B and D are the vertices that are airports. Okay, and then what are the airport vertex of that attributes? It might be an international airport or a domestic airport or any kind of thing. Okay, and after that, what is edges? That means the path, that means A to B or A to C or B to C or C to D. So those are all called the routes. Okay, and what all that routes will be? That will be like a there might be having a path available, or due to some issues that path might have not available. So these kind of problems will be there. Okay, so let's okay, so first of all, why we are moving to this graph? Okay, that should be your question, right? So this graph provides a better way of dealing with abstract concept with the relationship and interactions. That means in this particular airline problem, of course it is going to have a relationship between the nearby airports, right? So that kind of problem, the graph is the only best solution it will provide. Okay, so that is why we are just moving to this particular graph. Okay, and then you can easily visualize those things by using this particular graph concept, and it will be easier for you to understand as well. Okay, so that is one of the thing. And the other thing is it is going to have a neural network framework. Okay, and it in that particular neural network format, it is going to use the directed acyclic graph. That means it is like a in previously I explained you something called directed graph, right? So what is directed acyclic graph means? It will not have any cycles. That means if you start from the source and destination, you will not come again to the source to reach that some of the other destination. Okay, that means you never need to. For example, let's assume like you are just boarding from Chennai. Okay, from Chennai you are boarding, and then you wanted to reach the Mumbai airport. Okay, so in that particular thing, and after that you wanted to reach Delhi. Okay, so there are three locations here now. So what is directed acyclic graph means? From Chennai is your boarding point. Now you are going to Mumbai and Delhi. So if there is Mumbai is not that particular airport is not working at that particular moment, or any other issues, there might be no plane or everything is filled or booked. You will be not coming back to Mumbai after reaching to. Sorry, you will be not moving back to Chennai after reaching to Mumbai. Okay, you will be moving nearby any of the other airports. It will check for some other Hyderabad airport or some other airport. Okay, so that is called as, it will be not giving the back cycle. Okay, that is one of the thing. So that is the advantage of why we are picking to this particular graph theory. Okay, and after that there are plenty of other examples this particular graph theory is going to give. That is for example, social network, fraud pattern, and then power consumption pattern, and few other things related to this or being solved by this graph. That's why we are picking this graph theory. Okay, so now it's a poll time.
Hello, everyone. I am back. Please go ahead with the poll. And the poll will be there for 30 more seconds. After the poll, I want everyone to acknowledge it again on Q&A, because I see that a lot of you are using Instagram and not attending the webinar properly. All right, last 10 seconds and we'll close the poll. Any guesses what is the right answer? So as I'm not sure if you'll be able to see the percentage of people who have answered. So 15% have said edge, 8% have said vertices, and then 15% again for node, and 62% have said the answer is tree. What do you think would be the right answer? I want everyone to quickly write it down in the Q&A. I have not seen many responses in the Q&A. I'm sure that you're not attending the webinar. Can you guys quickly answer on right? I see a few people writing now. All right, the right answer is tree. So 62% of you are correct, and those are the people who are listening. Other than that, I'm not sure what you are doing. So please stop doing that and continue here in the webinar. All right. Veda, please take it over again.
Sure. So now let's move to the topic called how this graph theory is going to use for solving this particular airline problem. Okay. So first of all, there is a concept called shortest path algorithm, right? So before explaining about the airline problems and all, what is the common solution of all those four problems which I have listed down? That is identifying the nearby airports, right? So that kind of problem we can identify those particular nearby things by this shortest path algorithm. Okay, so I will explain each and everything in a clearer manner in an upcoming slides. Okay, so what is this shortest path algorithm? That means it will find the distance of that particular location and also by the air time or the traveling time. So that kind of things it will keep that as an attribute, and then it will find the shortest path. Okay, so the approximate solution, it will be the exact solution for this particular airline problem. Okay, so now there is an just think about there is a flight, okay, and then it is readily available for you to just on board. Okay, so that is the particular thing. So in that thing, while you are or the airline is having some issue and you really wanted to drop down of that particular airplane, okay, at that particular moment while you are searching or you are asking for the same airline to book you for another flight to your particular destination, so this particular graph theory is going to give you a solution, okay, by using this shortest path algorithm. Okay, I will explain those things here. So what is shortest path algorithm means? In this particular shortest path problem, you will be finding the path between two vertices. That means your source and destination. Okay, that is you can imagine like that, source and then destination. So there are four shortest path problem. So what is that? One is the single pair shortest path problem. That means it will be the it will find the shortest path between the pair of vertices. That means A and B. You can imagine that particular graph now. So A and B. So that will be the single pair shortest problem. That means from A and B alone, the two vertices alone. And second is single source shortest path problem. That means finding the shortest pair between the pair of vertices. That means A to B and C to D. So in between those two things, you will be finding the path, means that will come under single source shortest path problem. Okay, and the third thing is single destination shortest path problem. Okay, in this particular thing, you will be finding the shortest pair between the pair of vertices. It will also be the same thing, but the scenario is even you reach your source, you are picking that A, you wanted to go to A to B or A to D you wanted to go. Okay, even this in the source itself there is a problem in any of the airport or airline, then it will use the single source shortest path problem for identifying the this particular vertices to another vertices. Okay, so that is the source thing. So now the third, that is destination, means you reach the source and then while you are reaching the destination, in that particular moment, if there is any issue in the destination particular airport or there is any problem, it will find for the some other vertices to land that particular airport. So this is called as single destination shortest path. problem. Okay. Then finally, the fourth thing is all pairs shortest path problem. Okay, this particular thing is going to be much interesting. It is going to be finding the shortest path between all pair of vertices. That means every airline will have this all pairs shortest path problem solutions. Okay, because they cannot predict anything, right? So if there is any problem is going to come, or if there is anything particular thing is going to come, they cannot predict something based out of it. Of course they will predict the 50% of the thing, and that's why they are finding the all path shortest path problem, right? So in that particular thing, they will always have the entire route map. Okay, so entire route map, and then they will have all the destination and source, and if they are just feeding that, they will have all the details. Okay, so the fourth one is the important thing. So the above three is once the problem is occurs, and then they can apply these three problems. But before itself, beforehand, they will be having this all pairs vertices to that particular graph for finding the shortest path. Okay, so that the four important things you wanted to keep it in your mind. And now there is an algorithm. Okay, so there are five algorithms here. So first one is breadth first search and Dijistra's algorithm, and Bellman-Ford algorithm, A-star algorithm, and Floyd-Warshall algorithm. So there are four kind of algorithm. This particular shortest path problem is going to solve by using the graph theory data structure. Okay, so that's what our main thing is. Now this breadth first search is like it is going to find the shortest path for unweighted graph. That means it will never give any weight or the traveling time. So that kind of things, in that particular thing, you can use that breadth first search. So Dijistra's algorithm, so this is one of the important algorithm. We are going to use this to solve the shortest path problem of airline. Okay, so Dijistra's algorithm is the thing called, it solved the single source shortest path problem of the graph with non-negative edge weights. That means, what is weight means? The time. Okay, just imagine from the A source to B destination, what is the time? That is going to be the weight. Okay, just imagine that is going to be the weight. So in this particular thing, this Dijistra's algorithm will give an exact solution for that kind of problems. And another thing is Bellman-Ford algorithm. So what is this? This will be like the when the edges or the weight is in a negative format. Okay, that in that particular case, you can use this Bellman-Ford algorithm. And then the another thing is A-star algorithm. In this particular A-star algorithm, it is like in, while you want to speed your search, this is a searching algorithm. Okay, meanwhile breadth first search and A-star algorithm is going to be coming under the searching algorithm. Okay, so now it will give the output or the search result in a very quick manner or in an efficient manner. That's it. Now Floyd-Warshall algorithm, this particular thing will be like when the edges are negative, and what is the thing, it will solving the all pair shortest path problem, right? So that is the important thing. So now based on our requirement, the Dijistra's algorithm is the thing which we are going to implement. Okay, so now let's move to the demonstration. Okay, okay, now in this particular thing, we are just going to use the inbuilt library of Python. So what is the way we are going to solve this particular thing? That is by solving it by using the language called Python, right? So let's get started with that. First of all, what is the thing you wanted to have is, you wanted to have the NumPy thing. So NumPy is a library in Python. We can use that particular NumPy for the solution. Okay, so this is one of the thing. And after that, you wanted to have pandas. Okay, So I'm just importing these two things now, and after that I just downloaded the data of an airline company which is US based. Okay, I will just load that and show you how the data are loaded. Okay, so let's get started by using this pandas library. Okay, pd dot read excel. Okay, see, you can able to see this particular data, right? So inside this particular excel, what is the data from the airplane industry? It is like the departure time, the scheduled departure time, the delay, the air time, the scheduled air time, and then the delay, carrier, flight, tail number, origin, destination, air time, distance. So there are plenty of things are available. Okay, there is a called as the standard time, and there are totally 100 rows and then 19 columns. Okay, these are all the inputs you are going to see, and meanwhile I can show you the columns. Okay, these are the columns which this particular data does Excel is going to have. Okay, so now I'm just going to introduce you with one another library. Okay, that is called Network X. Okay, by using that particular thing called Network X, that this particular thing is going to download or get the edges and vertices and also the nodes for you. Okay, so this particular Network X library is going to help those things. So let's use that. Okay, and we just imported that. Now it is like I'm just going to create a variable. See, there is a function inside this particular network. It is like from any of the pandas. See, we already created a pandas thing, that is a pandas data structure. It is in a format of Excel. For example, there are three types of data structures in the pandas, right? So I hope a few of the guys might know. What is that? That is data frame, series, and the link. So these are all the three types of data structures present inside that pandas. So meanwhile, you just added the pandas in the particular thing. So this network thing is going to have a function called from pandas underscore edge list. Okay, this particular function will help you to get the source and destination. Okay, let's pass the value now. So what is the value here? That is data. Okay, so let's pass this data, and after that there is a attribute called source. Okay, you just wanted to feed the source here, and targets. Okay, and then meanwhile the edge attribute. Okay, that is the important attribute you just wanted to add. That is, while you give this edge attribute as true, then it will get the entire thing. Okay, so let's print this. See, there are totally 36 nodes and 57 edges. Okay, so let's try to print that. Okay, Now it is nodes. So these are the nodes. Nodes means it is a vertices. Okay. Now it is edges. Okay. What is edges means? What is the path from starting edges to one vertices to another vertices? Okay. So this particular node is otherwise called as vertices. Okay. This is like another term. That's it. Okay. So let's try to print this edges. See guys. So these are the edges from each and every vertices. That means you can move from here to here or any way. So these are all the available edges. Okay. So this is the demonstration of it. And so what are the things we just exploded? So we got the data now, and finally we use that network X library to get the thing, and now it is the nodes and edges. Okay. Now okay, first of all, you need to visualize this particular data, right? So how to visualize this? So Python is having a package called matplotlib. Okay. So by using this matplotlib concept, you can visualize the data. There are plenty of other libraries are available to visualizing, something like matplotlib, seaborn, or there are a plotly. There are plenty of libraries. So now I'm just going to demonstrate by using the matplotlib concept. Okay, so let's get started. Okay, I just imported the matplotlib library, and inside that there is a concept called pyplot. Okay, so I'm just using that as an alias name. Okay, you can always give it as PLT or any other name which you wish. Okay, so I just imported that. Now we can use this particular matplotlib thing to visualize the data which we have got in the Excel file. Okay, so let's see how we can able to see that. I'm just going to create a figure with the figure size of, this is the customized thing. Okay, you can give it up to your wish. It's not any mandatory thing, you just wanted to always give. Now using this network X, you imported that pandas data and then you assign that to the variable called df, right? So now what is the thing we just wanted to do? We are just going to plot that particular x nx. That's it. Okay, let's see. This is the syntax of drawing the network. Okay, so inside that we need to pass the data along with the, if you want to have the labels, you can give it like that. Okay, so first of all, what is the data? That is df, right? We can able to correlate here. So this is the data from origin to destination. So this particular thing df, and then do you need to have the labels? Of course we need, because then only we can identify with which is JFK, which is AATL, where is BOS, that is Boston. So how you can just give it. Okay, so with labels is equal to true. Okay, let's see that. It just beautifully printed the entire data. So what is this particular thing, guys? This is the entire data from this Excel. Okay. See here, this is the entire graph. That means these are all the vertices and this to this. For example, BHM to LGA. This is a edge. Okay. So how many edges are totally here? There are 57 edges and 36 nodes. Okay. So this is the single data of an airplane industry. Okay. Now let's see what is the how to find some of the, I'm just going to give one source and destination, and then we are just going to find the path. Okay. So let's see how to identify that. So shortest path distance. Okay. I'm just going to give it like this. Now, I already informed you some algorithm here, right? So what is the finding algorithm here? That is Digistrust algorithm. So we used this library called Network X, right? That is given as a alias name of NX. So this Network X, this is going to have an enormous of advantage, guys. Okay, so this will have an inbuilt algorithm as function, and also it can able to get the data from pandas. So there are plenty of advantages by using this network X. So while you are learning the Python and these kind of graph kind of things and all, learn about pandas, NumPy, network X, and for visualization use matplotlib. Okay, so I'm just going to use this network X again. And now I'm just going to use the Digistrust algorithm. That means it is already having the Digistrust one. Okay. So here I'm just going to pass the value here, that is df. Now I will change the source. Okay. So source is equal to, and then target is equal to, okay, let's pick some of the value here. Okay. So what it be? Okay, we will find source as JFX, okay, and then we will find it from some other destination. Okay, let's pick DFW. So source will be JAX and destination is DFW. Okay, so I'm just going to feed that thing now, JAX, and target as DFW. Okay, that's it. Now, what is the weight? That is distance. Okay, I'm just going to give the weight as distance. That's it. Okay, now let's try to print this SPD. Okay, let's see it is directly giving the solution. Okay, what is that? From JAX I wanted to move to DFW. Okay, so what is the shortest path we can find? So let's see here. What is this? JX, after that JFK, that means JX to JFK, and then SEA. Where is SEA? See, it is going to give it like that, and finally the destination is D, F, and W. Okay, so that is how you are just going to move that. So there are plenty of ways available here, right? See, while you are seeing that in a naked eye, while you are seeing this, hey, we can just move here, here, here to here. But by using this Digistrust path, this is giving a solution from JAX, JFW, SEA, and then EWR, and then finally DFW. So this is the, while just it will find the all path and then only finally give the shortest path by using this Digistrust algorithm. Okay, so that is how you are just going to find this thing. So now I will just show you the weight with air time. Okay, so this is by distance. Okay, so by distance you are good, but at the any passenger should want to reach that by time as well. Okay, so let's give the attribute as air time and we will check. Okay, that is the timing. This one is for by distance, and now this is by air time. Let's check. Okay, what is that? Shortest path by air time. Okay, something called SPA. It is the same thing, same disastrous path we are just going to use. Same attribute. We can just use the same attribute here. Okay. Now the weight is going to be the what? The air time, right? So that is the only thing we are just going to update. Okay. Something called air time. Okay. So that's it. Now let's print the SPA. Okay. See, by giving the air time also, this particular JAX is having the DFW along with the same location only. That means it will be moving from JAX, JFW, SEA, EWR, and then finally DFW. Meanwhile, you wanted to check with both the things. See, the passenger can ask, see, this is the distance is very low, but even though the air time is, if that is having a too much of waiting time in some airport, then it will be a con, right? So that's how the airplane will always, that particular industry will always check the distance and also the air time. Okay, so this is the demonstration of the particular thing with graph theory. Okay, so the basic thing you wanted to understand is using the graph theory, you are just using the shortest path problem. In the shortest path problem, there are plenty of algorithms found out there. We are using the Dijistrus algorithm for finding the shortest path from the source to destination. Okay, so this is the demonstration of the particular thing, guys. So now it is a poll time 2.
All right, guys, we have another poll here, and we have 1 minute to quickly answer this poll. I'll be waiting for you to quickly answer this poll. I hope you all are active in the session. I want at least, 80-90% of the students to answer this correctly, because this is really easy. If you know what all these different kinds of algorithms do, you'll for sure be able to answer this question. All right. My assumption was not very good. Okay. So breadth first search, you have, 9% of the people have selected that as an answer. Dijkastra algorithm, we have 45% of the people answering that, and all of the above 45%. Any guesses what is the right answer? Okay, so it was all of the above, which was the right answer. Okay. Please make sure that you listen to this, because this was a fairly easy question. There are still few people in chat writing A and B as an answer, but that's incorrect. All of those algorithms were the right answer. All right, Veda, please take over.
Sure. So we understand the graph theory, right? So now here, before understanding this entire graph theory, what is the other kind of applications you can apply to this particular thing? That is the thing you wanted to understand. Okay, in this particular, airline is one of the problem statement. And what else we can check? Something like a network. Okay, let's assume for an example, if a particular network provider is working on, and then if a particular hub or if a router is wanted to set up in a particular location, they will also use this graph theory. Okay, so while you are listening or reading about any of the data structure in any of the particular language which you wish to learn, that is perfectly fine. Always learn that particular data structure along with the real-time application. That is the one of the important thing while you are going to work or while you are going to implement that as a developer or going for an interview. So each and every person will ask the only the real-time application. One the first basic thing is you wanted to have a strong understanding of that particular algorithm or data structure, and then second thing, you need to have an always have a real-time application. If anyone is going to ask or not while you are learning about DSA, just pick the algorithm graph theory and then pick the real-time problem with that. So this airline algorithm is one of the examples. So you can use it in anywhere. Okay, so this is the one of the thing, and we can just move to poll 3. Okay,
All right, we have a poll 3 here. Find the odd characteristics of Dijkastra algorithm. You have 4 options and 1 minute to answer the question. Okay, last 15 seconds. All right, we will be ending this poll now. And what is the right answer? Any guesses? Again, very difference of opinion. Uh, People have selected A, 8%. 23% of people have selected B. 38% have selected C, and data includes text, video, and audio can be solved. 31% of people have selected that, and that is absolutely the right answer, which is D. We can solve, data which includes text, videos, and audio with Discast algorithm. All right, we'll move on with the session.
sure. So the entire thing of demonstration and understanding of this particular graph theory along with the airline problem, that is perfectly fine. So the final thing, what is the reason or what is the thing you wanted to learn this particular thing? That will be the how much numbers you are going to bring to your particular table as a Python developer. Okay. So meanwhile, comparative to any other particular language, Python is going to give a it is an open source. Okay, that is the one of the important thing why you want to learn that particular Python language, and it is going to have a plenty of advantages. That is, it is just having a plenty of libraries like NumPy, Pandas, Matplotlib, and whatnot, Network X. There are plenty of libraries present out of there. So learning any Python, learning the Python language and implementing any of the data structures algorithm, or you can just switch to any of the platform which you want will be wishing. Okay, so Python is one of the important language. So by learning that Python, what is the thing you are going to bring to your table? That will be the part of this particular slide. So it will be starting from as a intern or as a very beginner, you will be getting a 6 LPA and max up to 12 LPA. And also if you're just upgrading with that Python libraries and more in that particular Python, you can max up to 12 or 15 or 18. That's up to based on your range and your companies which you are choosing. Okay, so this is what I wanted to inform you guys, and I leave you here. Thank you.
Oh, I'm so sorry. I'm talking on mute. My bad. We have come to the last leg of this webinar, where we'll be having a Q&A session. If you have any technical questions, anything that you want to know, we'll be happy to answer your questions. Please shoot them on Q&A, and I will be picking them one by one. So Sumit Prajapati, I think this question has already been answered. I'm not sure. I don't know the context. So Sumit, could you please describe this question one more time? Others, if you have any questions, we can go ahead with them. Guys, no questions? Can we get dataset file and Jupyter file? Kunal Kumawat is asking a question. Veda, can we do that?
Yeah, yes. First of all, Prim's algorithm and Kreskel algorithm will coming under the minimum spanning tree. That means it is the entire different problem. Okay, so there are two kind of problem. This particular thing will come under the single shortest path algorithm. Okay, so what is Prim's and Kreskel? While you are wanted to minimize your cost or that particular thing and all, you will be using the Prim's and Kreskel algorithm. Okay, so there are plenty of algorithms present inside that particular graph algorithm, but picking the optimal solution is the wisest idea, right? So there are plenty of feasible solutions, but picking the optimal solution is always the recommendable. Okay.
All right. We can use Prism algorithm and Kreskel also. I'm not sure what does that means. For what context you're talking about? Veda, could you please help Sumit answer his question?
Sure, that's the thing. So this particular Prim's in Kreskel will be coming under minimum spanning tree. Yeah.
All right. Guys, any more questions before we launch our next poll? I believe that you guys do not have any question at this moment. All right. In that case, we will be launching our last poll for the day. All right. Do you want to know more information about the course that we offer? It is going to be on, full stack development. So if in case you're interested, you want to know more about the course, what is there, what is the duration, how we can help you, how is the structure, please select yes. So one of our academic counselors or me will get in touch with you. All right. So I still see about 55 people here. Please select the option so that we can get in touch with you. If you have anything that you want to ask, please go ahead and ask it in the Q&A section. All right, we'll be ending the poll in the next 10 seconds. All right, guys. So with that, we have come to the end of this session. We hope you have a great day, and we will be having other Guru classes in the following Saturdays. Please feel free to join and learn with us. All right. Thank you. Have a good one. Bye-bye.